So I would like to thank everybody who is connected for this workshop. So today's workshop, INFINITECH workshop, this is a project that is a flagship project for artificial intelligence, big data, and Internet of Things in digital finance. We've got a series of workshops covering almost all high-tech areas of the sector. Today's workshop is dedicated to artificial intelligence for portfolio risk assessment. So we are focusing on presentations that have to do how artificial intelligence is disrupting things like investments, trading, asset management, and so on. So having said that, and before going to the technical content of the workshop, which is excellent, I would like to ask the coordinator of INFINITECH Project, Ernesto Troiano, to make a short introduction and welcome on behalf of the project, and then we can continue with the agenda. Thanks again to everybody who is connected. Ernesto, we can see we can see already your presentation.
Okay. Thank you, John, and welcome to all the participants to this workshop, which is, I like to underline, organized under the umbrella of this project, the INFINITECH Project. The INFINITECH Project is one of the lighthouse projects in H2020, a huge project with more than 50 participants, with a significant budget and funding from the European Commission, and it's one of the few dedicated to the financial sector. The financial sector is not neglected, but underrated in the ecosystem of the H2020 project, and we are proud, and I'm proud to manage and to coordinate this project. The project is about solving problems in the financial and insurance sector, old ones and new ones, with technologies like big data, analytics with machine learning, artificial intelligence, IoT, blockchain, you name it. So innovation in the financial sector, which is usually conservative when it comes to propose new feature, new services to the customer. But we really think that this project could advance some of the services. So today we will present, and I thank you all the speakers today for presenting this hot topic about the risk assessment managed with the technologies like artificial intelligence. So I'm not getting more time from you. So I really would like to thank you all for the participation, and please keep in touch with this project, checking out our communication site, infinitech-h2020.eu. Thank you so much. John, back to you and to the speakers. Thank you.
Thank you very much, Ernesto. So we can now do an introduction to the workshop and to the topic, of course, of the workshop. Let me share my presentation. I hope you will be able to see it. So I hope you are able to see my presentation. So just quickly, a few things about introducing our topic today. We know that artificial intelligence is having a disruptive impact in the digital finance sector, in the finance sector, including banks and financial technology enterprises. This is happening because nowadays we're having really a lot of data points to work with. inside the banks and inside the financial organizations, but also a lot of alternative data. So things you find in social media, in news, in different sources, so many more data points than ever before. And of course, we've got also banking regulations like BST2 that they are unlocking even more data. And we know that banks and financial organizations are undergoing a digital transformation, which is actually accelerating. So the more digital we have in the sector, the more data we have, and combined with the technology acceleration, AI, and so on, this creates a very powerful AI ecosystem and a lot of disruption in different applications. The main benefits, the main promise is here on the automation, on the accuracy of several processes, reduced operational costs, and so on. Well, in Europe, we have also some complex regulatory ecosystem, which, on the one hand, creates some concerns. Also, it's always challenging to comply to stringent regulations. On the other hand, as we said, it unblocks a lot of potential for AI, especially if we talk about the Second Payment Services Directive and open banking, which unblocks a lot of data and you can do more things with AI. On the other hand, in the topic that we are discussing today, we have other important regulations like the MiFID regulation, which is about transparency in research, in the profiling, in the investment recommendations, and also when you go to AI, which is a new topic, we need also to ensure that the recommendations that you give to customers are also transparent. And of course, the famous GDPR, which has again implications on AI because it's all about data and data protection. So the topic of using customer data becomes very sensitive and very much regulated due to GDPR. Now, in this landscape, AI is disrupting a lot of different applications. So today we are focusing on portfolio risk assessment, as I said, trading, investments, and how this can be made better for the customer and better for the financial institution with AI. But I've made also a list just to fix some ideas about how AI is disrupting the sector. So credit scoring, especially for small and medium enterprises, this is nowadays considered to become also statistical in several cases. This is very important for small medium businesses that with traditional credit scoring techniques do not have access to finance. So credit scoring based on machine learning is one big topic where AI is disrupting the sector. Of course, it's about fraud detection, being faster and more automated to detect patterns of fraudulent behavior, even sometimes hidden patterns that are not so obvious for the human, for the regulator to discover. And on the same line, anti-money laundering, again, in INFINITECH Project is working on all of these cases. So anti-money laundering, so how you can flag fast transactions, and looking not only on the conventional banking continuum, but also seeing, other things where crime is happening, like blockchain networks and cryptocurrencies, or even dark web and so on. We also pilot INFINITECH, and this is another area where we see disruption from AI on financial assistance, personal finance management, or finance management for the business. So how can AI help the customer and the bank to proactively do the financial planning for the customer? Again, in the customer-centric analytics, new product design, better KYC, and having a lot of data for the customer, you can analyze it and propose the right recommendations. In INFINITECH, we work also in a lot pilots of usage-based insurance. So how you can use real-world data to provide new calculations for healthcare premiums or premiums for car insurance, and this is also applicable for home insurance. So this is another case of AI disruption. Then if you just look at how much trading is done nowadays through robo-advisors, and again, this is AI software, you will see that this is increasing. We also hear in the news, I don't know, recently probably with a case of Robinhood and how many people were there, Acorn. So a lot of trading, a lot of investing is happening through robotic software. Now, today, we will especially shed light on the topic of personalized asset management. This is important for financial institutions, and this is important for the customers, but for us, we see one more, importance, which is having potential social impact as well. And this is that nowadays, the majority of citizens, so the majority of average citizens that they have, savings portfolios, which are, on the average or on the low side, they are completely excluded from high quality asset management services. Through artificial intelligence and automation, we envisage that they could gain access to such services, and we think that this is a democratization of asset management and of investments for lower portfolios, right? For normal savers that they have to do something with their money in a landscape, in a financial landscape where interest rates are zero or sometimes below zero. So this is what we are discussing today, and I think we have very good content. So there are overall 5 talks after this introduction, but I would say 5 talks clustered in 3 main topics. So first, we will discuss about customer risk assessment for personalized asset recommendations. So how AI can help asset managers, and this is the presentation from Privé, Austria. And then we will move on to the topic of personalized investment recommendations for the retail customers of a bank, and there we will have a presentation of National Bank of Greece, but also University of Glasgow that is working closely with a Greek bank on providing personalized and value-added recommendations. And then we will move to another pair of presentations that they are concerned, Forex trading, but in general, high-frequency trading. So trading that happens in real time or say semi-real time, that you can purchase and portfolios that you can build in short time scales. And we will have a presentation by JRC Capital Management in Germany and Innovax in Cyprus about how machine learning and artificial intelligence improves the value at risk calculations and how this can be beneficial for customers, for financial institutions, but all for regulators as well. Then we will be free in our program, so we have some demonstrators in the form of videos to show you. But I think this can be done in a row, so maybe each demonstrator will follow each presentation. So our program is quite flexible. I'm sure we will be on time. And I have a call for action for you, so we will administer a survey. We would like to get your feedback. This is very valuable for us. Don't just give us, good feedback, everything okay. If you see something you didn't like, or you think that some of the solutions doesn't have that much value proposition, feel free to give us this feedback, because we value it a lot in order to improve our systems and to improve our process as well. And most of you are registered, so we will give you the option to subscribe to the Infinitetech newsletter and to the marketplace that we will launch later this month with tens of different assets for artificial intelligence on different digital finance, so assets for different applications and in different technical assets and complementary assets. So how you build things, but also trainings and so on. So thank you very much. And without any further, because we've taken a couple of minutes more than expected, I would like to give the floor to Privé for their presentations on how AI is disrupting asset management in their viewpoint and business strategy. Yeah, Pablo, I think you can try share your screen.
Yes. Okay. Yeah. Thank you very much, John, for the introduction. We're very happy to be here. So let me quickly share my screen. May deactivate my camera to avoid any lag in my presentation. Can you see my screen now?
Yes, we can see it. You can go on.
Perfect. Okay. Yeah. So first of all, thank you very much for having us here. We just want to make a quick introduction today of what we are working on around the optimization process that we are building for our pilot for within the INFINITECH project. In this case, or in this presentation, we are focusing on this so-called data-driven customer risk assessment for portfolio recommendations, which is part of the user journey that will be integrated on our optimization process after that. So yeah, so as you can see here, more or less, we want to cover just to make a quick recap of what our pilot 4 is about for everybody to be on the same page, and then we will just directly move to the customer risk assessment journey. So first of all, we just wanted to make sure that we're all aligned in this sense. Yes, some of us are working together in this pilot for. But anyway, so what we're building out here is basically a algorithm, a AI-based algorithm for portfolio construction. So very simply said, based on some inputs, which in this case we call fitness factors, because are factors that are basically selected as preferences from the investor or potential investor in this case. We use these inputs on our optimization process to generate a portfolio. And as you can see here in this screen, some of these inputs could be, a forex minimization factor that the investor is selecting, or maybe some diversification in the portfolio. The investor may say, I would like to have a portfolio that's very diversified, so we could optimize the proposal based on this preference. Also, some investors could say, I would like to optimize based on performance. I'm not worried about my risk, but my overall performance at the end of the year. Or maybe I want to optimize based on volatility or the Sharpe ratio. So this is what we call each of these factors is what we call our fitness factors. And based on that, we will generate a optimized portfolio. So without further ado, so first of all, John, I just want to confirm, do we want to have in between questions during the presentation, or we just basically move the questions at the end of it?
We will get any questions at the end, 1 or 2 questions, and then, also at the end of the workshop, we have a slot for extra questions. So, and of course, everybody is free, to ask at the end of the presentation, but you can also type, and we are happy to answer the questions if you just type them on the chat.
Sure. Yeah, perfect. Okay. Yeah, so as you can see here, we wanted to represent the journey in sort of a simplified workflow to make it easier to understand. So as you can see here, what I'm going to show after this is the first part where we start the journey and the client enters the system. After that, we jump directly to the risk profiling questionnaire. So we will go through this. It's basically a series of questions where what we're basically going to try to do is to assess the risk aversion or the risk profile of the investor or potential investor. So based on that, Once we get the risk profile, we jump quickly to the preferences selection, where here basically the investor or potential investor will select a set of themes that the investor will be interested in. Based on these inputs that we discussed before, we gather up these data points from the front end, integrated in the back end on our optimization process. And this is where the AI gets triggered. And based on this, we generate a proposed portfolio. We could actually make here a retroalimentation where we say, is the customer happy with this, yes or no? If not, then we could fill in the questionnaire again and also make a new selection of preferences until the investor is happy with the proposed portfolio. And then we just generate the final proposal. So yeah, little disclaimer here. We just wanted to make sure that that these are just mock-ups that we're working on. So these are not definite screens. So so this is the first screen. We could actually ask the client or the investor, do you want to conduct a risk evaluation, or do you want to enter your risk score directly? So in this case, we want to evaluate the risk profile of the client. So we jump to this step 3 in the diagram, where we say we want to fill in the questionnaire. So the questionnaire has several questions where, as said, we want to assess the risk return kind of goals or preferences that the investor would like to have. So as you can see here, the first question relates to the policy terms in terms of years, up to 12 years, 20 years, 30 years. In this example, we select up to 20 years. The next question relates to the payments, so the frequency of the contributions. In this case, we have a frequent contribution or just one-time payment. We select frequent contribution for our example. We have another question regarding the wealth of the investor. So basically, how much do you want to contribute monthly, and what is your monthly free available income? So this is also a question where we are trying to assess the exposure of the investor in this portfolio regarding to his or her wealth. The next question relates to the experience of the investor. So we basically ask, which of these asset classes are you familiar with? We select fixed income, equity, and commodities. Commodities, are familiar or known for me. So the next question, pretty important question, where we basically try to assess the expectations of the investor. So as you can see here in this chart, we basically have 4 historical hypothetical performances of 4 different portfolios. And what we're trying to assess here is, from the investor point of view, where will you be comfortable with? Would you be comfortable with the green line or maybe with the blue line? Do you like, this peaks and drops of your portfolio, have this bigger drawdowns, or do you? But obviously, having higher risk here implies higher return, or do you prefer a low return, but your portfolio doesn't fluctuate so much, so the implied volatility of the portfolio is lower? So in this case, we select the green line, which we transform in the backend with a 70% equity globally, 30% fixed income. We have another question which relates more than for the return, but for the risk of the portfolio. So as you can see here, during the financial crisis from 2008 to 2009, which of these interim impairments are acceptable to you? And we also, here in this case, we want to try to assess the risk aversion of the investor and see with which sort of a drawdown will you be comfortable with. So in this case, we select this blue line, which basically transforms it into 40% equities globally and 60% fixed income. In this case, maybe some of you are thinking, there's a discrepancy, right, between this 40% and the 70% regarding risk and return. But that's fine. Those are just data sets that we will save, and then we will basically gather up all and make a consolidation of all the answers to conclude the risk profile for the investor. So another one, the investor type. What's your investment character? As you can see here, this is another risk return related question where we want to assess if you are a more defensive or offensive investor. In this case, we answer moderate. Another question which relates to basically the volatility of the portfolio. You can see here, we could have a higher return, but also we, as we say here, we will accept some larger fluctuations on the portfolio, or we prefer lower fluctuation, but this implies obviously a lower performance or return. So in this case, we select this one. We have another question regarding the risk. We basically ask, in order to achieve high return, we will obviously have fluctuations in the portfolio, right? So how will you feel if losses at the expiration date are shown in your portfolio? So 3 types of answers. We could say it makes me nervous, it makes me anxious, or maybe I am familiar with this and I know that risk and losses are part of the game. So this is another risk return and risk aversion question. We answer makes me anxious. In the next one, we try to assess volatility. And you can see here, let's assume you invested 10,000 euros in funds last year. Now you check your portfolio, right? And you see you have 8,500 euros. How do you feel? So do you panic and sell all funds? Do you understand that volatility is normal within your portfolio? Do you feel worried and reduce your investment, or do you take the opportunity and actually buy additional funds? So in this case, we answer, I feel worried and reduce my investment. And as said, each of these questions will have a numerical weighting. And based on that, we create a risk score. So in this case, you can see we obtain a risk score of 3. And our volatility of the portfolio, our target volatility, will be 9.4%. So as you can see here in the scale, we have a volatility scale between 3% minimum and 20% maximum. So we are more or less on a moderate, even a little bit of defensive, but overall moderate type of a portfolio. So this is basically the risk profiling assessment. I will just jump through quickly to the themes or preferences selection of the journey, where we basically have in this presentation, we added 3 types of questions. Do you want to be invested in sustainability funds? We could say yes, 100%, or neutral. I don't really care about sustainability funds, or I would like to have I prefer to have them, but it doesn't have to be 100% of the portfolio. So we have the same type of question for the ETFs. Do you want to have ETFs in your portfolio? Yes or no? And which type of themes? This is a very interesting question where we try to basically assess the themes where the investor is interested in. So you can see here environment protection, we have water, we have gold, megatrends is also a topic, technology, health. And then based on that, the client could say, the investor could say, I want to be exposed in impact investing, water, or I would like to be invested in funds. Yeah. Okay. So I would like to be invested in technology, mega trends, and so on. So based on that, we have a summary. This summary basically reflects the choices of the investor regarding the investment preferences. So as said before, each preference will be a fitness factor, which will act as a data set that will be an input for our optimizer. And here in the journey, you see, we could basically click here and say, show me my optimized portfolio. And then what the front end will do is gather up all these data sets and introduce them to the AI Go or AI optimization process. And then we get a proposed portfolio. So I know, John, we have a couple of minutes left. So just summarizing, we have a proposed portfolio here. In this case, we have something around 70% equity, 27% fixed income, and 3% cash. Our target volatility, 9.41%, a annualized return of 11.1% on a 5-year average in this case. You can see the performance of the portfolio and the basically the portfolio allocation where the portfolio will be invested in. You could actually come here and edit your portfolio and edit your preferences or your risk profile again if you're not happy with the results. And if you feel that you're happy with them, you could basically click and generate your final proposed portfolio where we could actually make a summary of it and actually even generate a PDF report where even the advisors could pick this PDF and show this to the investor or the potential investor and see, this was your previous portfolio. Now you have a better portfolio, or this is your new proposal. Are you comfortable with it or not? So I think, yeah, that's basically it, John. I don't want to take more time. So thank you very much, everybody, and feel free to ask us questions if you want now or maybe after all of the presentations as you prefer, John. And yeah, thank you for listening.
I don't know if there are any questions or somebody wants to ask. I see a question in the chat, and yeah, I would like also to add another question, and if you can, give us a short answer, and maybe if we have time in the end, we can go into more detail. So one question is, what algorithms do you use to produce the portfolio? I recall something genetic algorithms and so on. So that's one question, and another, which is actually my question, is that what is the distinguishing line between the mandatory customer information collection from MiFID and what you do here? So which part is sort of mandatory that any wealth management department of bank or asset management would do anyway, because this is what you do to discover the risk aversion of the customer. This is imposed by the regulation. And what is the part which is extra, so that you add it in order to make your like this or not? So these are the two questions, for the algorithms and second for the MiFID. Pablo.
Yeah, so maybe for the first one, we basically are working on a genetic algorithm concept where, as you can see here, we have several iterations for the optimization process, where based on the fitness factors, the algorithm generates basically 100 proposals. And then based on the preferences, we select the highest ranked proposals. And then we basically optimize these proposals again and generate a new set of generations. And we make several iterations for that until we get a high level of confidence that this will be the best portfolio based on the statistical generations of the proposed portfolios. we basically realized that after 100 or maybe 1,000 iterations, we basically are having variations of the risk return of maybe 0.01%. So then we basically assume, okay, this is enough for have this best portfolio. So this is basically what we're working on right now. And what's interesting is this fitness factors, because this maybe relates a little bit of your second question, where we assess the preferences and the needs of the investor, and based on that we generate these generations of portfolios. So I'm not sure if this answered your question.
John, potentially may I add, especially to this regulatory path? Yeah, the regulatory, as you mentioned, is always related to the know-how parameters of the customers, the experience, his financial stability. As you have seen the question, you cannot invest 2,000 euros per month if you only have a monthly income of 2,000 euro, because you need something for your living and so on. Yeah, and therefore this is the regulatory path, to have all these, let's call it the MiFID II compliant risk awareness, know-how and capabilities questions. Yeah? While the add-on, which is the combination which we make here, is this what we call the personalization part. Yeah, because normally if you right now go to a bank, you normally get your questionnaire, then you answer your questions, and then you can get a kind of let's call it sample portfolio. Yeah, if you have a portfolio for 50-50 equities bonds, because that fits to your risk score, then you get it. Yeah, while here the enhancement is that you as the investor can then announce additional preferences like sustainability, like themes, electromobility, e-health, aging, now pharmaceutical industry with COVID and all these kind of things. This is, let's say this is the voluntary part, but I think this is the more important part for the single investor, yeah? Because the other part is the stuff which anyway needs to be done and you get everywhere. But this combination of this regulatory path together with this personalized portfolio construction tools, yeah, this is exactly what we try to figure out here. Yeah? And potentially one additional sentence to the algorithms. The approach here is that we do not use only one type of algorithm like a value at risk model would do, or like Markowitz has done. Yeah, we try to combine the different algorithms here into this genetic optimization process to have a more stable results in the end. Yeah, because we know all these, let's call it single methodology algorithms, they have all good phases and they have phases where they do not perform so good. Yeah, and that shall be aligned by using different algorithms in one platform to have this genetic how to say evolution of getting better and better portfolios with each step of optimization. Yeah, this is a little bit the idea behind the genetic optimization. Yeah.
Very good. I mean, that answered my question. Of course, some follow up, maybe see them in the end. So I would say that we do the presentation of National Bank of Greece and Nicholas. And yes, in the end, I think we can, revisit if we have the time,
Oh, thank you very much. Yeah.
Perfect. Thank you very much.
Thank you very much, Roland and Pablo. Very nice presentation.
Okay, can you see my screen?
Yes, Nikos, please go on.
Okay. So, John, thanks for having us here. Good morning, everyone. My name is Nikos Droukas, and I'm here to talk to you about an automated, personalized investment recommendation system for retail customers that we have been building. And first of all, I would like to say a few words about the bank. National Bank of Greece was established in 1841 and became the first bank in the modern Greek state, with a significant contribution to the financial life during these 180 years of history. Nowadays, National Bank leads one of the largest and strongest financial groups in Greece, with presence in Southern Europe and Eastern Mediterranean. it would be fair to say that the National Bank of Greece is one of the major pillars of the Greek economy, as it controls 1/4 of the retail banking market and has more than 1/3 of market share in deposits. This share of deposits reflects the confidence of the savings customers, who are our driving force. It has also the largest customer base with more than 6 million active customers. Now, we offer a broad range of financial products and services that meet the ever-changing needs of businesses and individuals. And in order to do so, we leverage on the knowledge that we extract from our data. For this purpose, National Bank of Greece has created an analytics center of excellence in order to better understand the customer's needs and requirements on an ongoing basis and adapt to them. In this COE, we have formed a team of experienced professionals that offers analytic services of the highest standards across the bank. We have been developing analytics use cases which are customer-centric, and our motto is serving the customer with the right offer of the right product at the right moment. Sorry. Now, having strategically decided to offer personalized offers to the customer, we participate in the INFINITECH project. As most of us know, this is a joint effort of global forces of finance, insurance companies, and universities to drive innovation using big data and artificial intelligence. Towards this direction, we are participating with a pilot project named an automated personalized investment recommendation system for retail customers. The ambition of this project is to optimize the operations of the bank, and to be more precise, it will significantly automate the process of providing investment recommendations, while at the same time ensuring that these recommendations are more tailored, effective, and overall more acceptable from the customer side. The outcome of this pilot will be an artificial intelligence system for personalized investment recommendations that will provide the relationship managers of the bank a set of investment solutions, recommended solutions, for every customer that they interact with. In order to achieve this, we have established collaborations with other participating organizations of the consortium, such as Crowd Policy, who are an integrator of INFINITECH technologies and also develop visual representation components, Ubitech and LinuxScale, who have offered technical building blocks such as the testbed and the data storage as a service, ReportBrain as a provider of alternative data sources such as news analysis and economic sentiment extraction from blog posts, the University of Glasgow as experts in development of machine learning algorithms, and later on we'll see in more detail how we leverage on their expertise, and of course ourselves, who will be the main data provider and also the product owners. Now, we could say that we are going to reach the full operationalization of the project through 4 streams: the data extraction, storage, and processing, the investment risk profile creation, which is the first service of the project, the asset categorization, so that we classify the investment options into similar groups, the system for personalized investment recommendations, which will be the core service of the project, and of course, the implementation of the investment recommendation, which consists of the way that recommendations will be offered to the customer. And now that we have seen the project implementation steps in a high level, we can go through each one in more detail. The data sources are going to be accounts transactions data, which comprise of mainly deposit account transactions and investment related transactions, cards transactions data in order to see the customers' everyday transactions with the bank, CRM data, which will mostly be demographics and products that the customer possesses, assets historical prices, which are publicly available and inform us about the special characteristics such as the volatility, the trends, etc. So that the investment assets are going to be categorized according to their type, their maturity, the investment horizon, and volatility. By combining customer and assets data together with CRM data, we are generating an investment risk profile for every customer. The profiles range from completely risk-averse, moderately defensive, balanced, up to the most aggressive one. So every customer of the bank will be attributed to one of these grades of risk aversion. For this component, we have been using mainly open source code and a few other internal analytical methodologies. Moving on to the core system development, which is the recommendation engine, it will be trained using the investment risk capacity that we discussed about, and together with asset classes as they were defined in previous steps. We will also incorporate the different behavior of customers of different investment risk profiles. That's why we used the data we showed you. Basically, the investment preferences and past purchases of investment assets are going to be incorporated into the mechanism, into the algorithm. The output will be a set of investment recommendations for every customer, such as Greek high-cap stocks or European high-yield bonds. I will not go into further technical details because our partner, Richard McGreedy from University of Glasgow, that will be involved in this part, will present a session especially for that. The next step is the implementation. Every relationship manager will be provided with a set of recommendations for every customer they want to serve. This is the point where we leverage on ReportBrain's contribution. I mean, before the relationship manager receives the optimal set of investment recommendations, there will be a decision layer, which is going to be applied. This takes advantage of the financial instrument sentiment data, which are going to be used to incorporate the market momentum. Thus, the priorities of weights of the asset classes that are provided by the recommendation system may change based on the output of this engine. And let me give you an example. Let us suppose that a customer is pre-assigned with a large cap stock recommendation, which was generated based on his investment profile and risk aversion. On the day that he meets with the RM, an event takes place which is not anticipated, and we can suppose that this event is capable of negatively affecting the economic sentiment for this specific asset class, for the large cap stocks. Then the algorithm will reach this piece of information, and the relationship manager will be provided with a different recommendation for the same customer. After the proposal is communicated to the customer, the relationship manager is going to receive his feedback, which will be saved and later used to enhance the algorithm for future recommendations. At this point, I would like to share with you a first draft of the graphical user interface that our partners, Crowd Policy, have prepared. So, as I told you, it is a draft screen, only indicative screens. This is the screen that the RM will see when they face the customer. They will see the recommendations and the reasons why these assets were selected for the customer. so they are more confident to communicate them. They will also have other figures related to the assets in a well-structured way. As we said in the beginning of the presentation, the targets of this pilot are an increase in retail operations productivity, increased volume of trading transactions, increased customer satisfaction, and of course, higher customer returns. There are 3 types of users for this pilot. The investment advisor will be able to provide tailored financial advice by taking advantage of the risk and the behavioral profiles of the entire bank clientele, not only for the existing investors, as it is the case right now. With this mechanism, they will feel more comfortable having information for the recommendations that they provide, and it is a way to increase their productivity and to strengthen the relationship with the customers. Second, the retail customers who will experience personalization in their investments by gaining access to a service previously offered only to the highest value customers. The outcome will be them to consider National Bank of Greece as their main financial services provider, and gradually, hopefully, turn exclusively to NBG for the entire spectrum of their financial advice, products, and services. Of course, the bank, as the third user, who will upgrade the customer experience by automating the process of providing investment recommendations for the retail customers of the bank. The bank also ensures that these recommendations are more tailored, effective, and more acceptable from the customer's side. So we're going to develop a better and more trustful relationship with customers and decrease the trading volumes that are associated with high-value retail customers. I think that these are the ways that we aim to see the enhanced productivity, the better advice for investments, and the increased trading volumes as outcomes from this initiative. And that's pretty much what the project is about. And I would like to thank you for your time, everyone.
Thank you, Nikos. We have a question in the chat, or I don't know if Christopher would like to ask this question, right, via audio. Christopher, maybe?
Yes, hello, this is Christopher Beveridis from Hypertech. Well, my question is, you mentioned that there are changes in the portfolio to be recommended. And my question is, how do you control the frequency of providing such recommendations, as we know that changing portfolio means cost to the customer due to commissions of actions that need to be taken. So what is the logic for controlling how frequent you issue such recommendations to the customer, if there is a logic?
Yes, I understand. Actually, the aim of this project is not to make active portfolio management. However, we need to be 100% sure what the right recommendation is for every customer. We won't be actively, as I said, managing the portfolio, but every time that someone comes into the branch, the relationship manager that is going to serve them has to know what is the best product for the best customer. We won't say that this portfolio needs to be optimized right now or in a few months or in a few weeks. But by assigning them into asset categories which are suitable for them, we can make sure that they have a good start in their investment experience. So
Nikos,
it will be a portfolio management in essence.
The start is clear, but I think the question is also how frequent you update. Is it push or is it pull? Or you expect the customer to come and ask, okay, I want to see how we can change my investments, or I want to invest more money, or there is also a possibility that you call him, right? And you ask him, okay, now it's time, to do something on your portfolio. I think that was the question, right? Because, every time that you do this change, okay, it's good for the bank because of the commissions and so on. But, for the customer, it has to be treated with caution because let's say the earnings, right, have to justify the commissions, right?
Exactly.
So I think,
I know what you mean, both of you. We have not designed yet a specific time frame. We have not decided upon a specific time frame for these investment options, the investment positions to be renewed. This is the dynamic thing that will happen for the customer with every time they need to do business with us in terms of investment activity. So if they are served by a relationship manager, he is the one that needs to know the exact position and the exact customer experience.
Okay, clear. So it's the human aspect there, it's not, the AI cannot do everything, right? So the human aspect here is also
Yes, you are
important,
correct.
right?
You are correct.
And it's good. I think this is a good message to mention, right, in the workshop that AI is at least currently an assistant, right, to the human. Is not coming, to completely replace, the people in the banks. Okay, maybe we revisit this topic. So I would suggest that before having any break, I know we've taken some more time, but I think we will overall be on time because we have some buffer time. So I suggest let's go to the more a technical part on the machine learning by University of Glasgow, right? Richard?
Yes.
Yeah, this is a dedicated session for this.
Okay, yes.
Let me share my screen. Nikos, do you just want to stop sharing?
Of course. The floor is yours, Richard.
Okay, can you see my screen okay?
Yes, Richard, and take your time because the program will go, will fit in the time. We will take some of the discussion time in the end. So no worries.
Okay, I've got quite a lot of slides, so to go over. Okay, so thanks. So yeah, I'm Richard McCready. I'm from the University of Glasgow. So we're a research institution that's taking part within the INFINITECH project. And what we're looking at primarily is the recommendation side, or how you go about producing these kind of financial asset recommendations that Nikos was just talking about. So one of the blocks there in terms of the overall system. So what am I going to cover in this talk? Well, I'm going to cover or break this into sort of three main sections. So first of all, I'm just going to give some quick sort of setting the scene for sort of personalized recommendation for investments and why we need artificial intelligence to kind of help us with that. I'm then going to talk a bit about how we can actually go about building these things and how we've been doing this in the INFINITECH project, and also give some hints about how you yourself could go out and make one of these yourself. And I'll end that with a short demonstration, just illustrating what this would look like in action using a initial prototype that we built. And then I'll end by just talking a bit about like where this field is going and where some of the advances that are being made right now will be able to really push forward this field of financial asset recommendation in the near future. So let's begin just by kind of setting the scene. I'll go over this quickly because Nikos has already covered some of this. So in terms of motivation, we're really living in a world where people are not sufficiently investing in their future, right? So I'm from the UK, so I'm just going to use UK numbers to illustrate this. About 35% of the UK population doesn't even have a pension, which is basically the lowest barrier to entry for investing. and about 43% of the population don't know how much they would actually need to save for their own retirement. And so there's really a need to try and promote investment, not only from the top 1 or 5%, but more widely across the population, so that we don't end up in a situation where we have a large portion of the population which just has to live off state benefit when they retire. And one way that we can go about doing this is make investment easier and more convenient and more understandable for the average customer. And so you could do this by trying to promote smaller scale investing, where you instead of maybe your customer going and buying a new TV, they instead just use that money to make a small investment for their future. And one of the easiest or most cost-effective ways of doing this in the UK is through things like stocks and shares ISAs. But only about 4 to 5% of the UK adult population has these. So this very much kind of shows, or the message I want to take away from this is that this is still, or investment in these kind of assets is still very much, a top 5% of the population task, right? So people are not typically investing, and we need to try and rectify this. So why are people not actually investing? Well, there's a wide range of reasons why people don't invest in their futures. Partially, it's because the financial domain is just really complex, and it's difficult for people to actually get the right knowledge to understand how to invest and what to invest in, and the large amounts of financial jargon doesn't help. It also just takes some time to be able to do the background research to try and understand, what are the implications for their investments, and what are they comfortable in investing in. And then along with that, we have to look at how do you go and measure risk for a particular customer, and how does a particular customer that maybe has never invested before understand how much risk they will or they should take on board. We also have increased barriers to entry, ironically, through our successes in making investment easier. So by providing easier vehicles for investment, and we've also dramatically increased the amount of choice that customers have. And this is leading to analysis paralysis, where you just show a customer hundreds and hundreds of different things they could invest in, and they have no idea what to select, so they invest in nothing. And a pertinent problem in sort of your current online environment is that there's a lot of different strategies for investment, and a lot of different conflicting advice that people can find online, and so it's unclear, where they should get, or what they should actually believe in, and who they can find people to trust for investment. So that gives you a bit of background on some of the problems. And so where we're coming from is we're coming from the perspective that we can't expect the average, man on the street or woman on the street to go and expect or to become a savvy investor on their own. It's just not practical given the real life constraints and their existing knowledge base to make them into really clued in investors who can navigate the market. And so what they need is an intelligent financial advisor to analyze their own position. So this is customize analyze what the particular constraints are for a particular customer, and then recommend assets or asset groups to invest in, which is going to be personalized to them. And what I refer to this as the insurance recommendation task. So recommending assets or groups of assets for people to invest in. Now, before moving forward, let's just quickly formalize what I mean by this insurance recommendation task, because this is going to define some of the experiments that we're going to do later, so it's good to understand this early. So we can look at this in terms of what are we taking as inputs and what are we trying to give as outputs. So this is a relatively complex recommendation tasks where we have a wide range of potential inputs, right? So we've actually already heard about some of these in the previous talks. So in terms of, we have some representation of our user. So this is our customer that's wanting to invest. And the first thing we might be doing is we might be collecting information about that customer via questionnaire. And you heard all about that during the first talk, where we're collecting things about, risk appetite, their income, like how much they're willing to spend, these types of metadata about the customer personally, and their particular financial situation. You might also have additional ancillary information, however. So if you're providing this as part of maybe a bank, then you probably also have ancillary data about that customer. So you have information about their purchase histories, maybe ongoing reoccurring payments. So you have some idea of how much they're spending each month. You have information about their salary, as well as potentially other large commitments that they have, like mortgages. And in a few cases, you may also have investment history. So this is about information about previous investments that they have made. But coming back to my initial point, this data is rare because most people don't invest. You then have information about the actual items that you're trying to recommend to the customer. So I'm just going to call these financial instruments or assets. This could cover a wide range of things, from bonds to stocks to currency, these types of things. And for each of these, you're likely to have current actual tracking information in terms of price histories, volume information, and from that you can also calculate other metrics. So you'll have risk estimators, such as alpha, beta, Sharpe ratio, these types of things. And you may also have some additional information about asset perception. So these would be things like analyzing the sentiment regarding the underlying company, for example, for a stock. And finally, I also define another category, which I'm just going to call environmental data here. So this is just a catch-all for other types of information about the environment in which the investment is potentially being made. So this might be overall market segment history or trends. And it also could be national things. For example, you might have tax breaks that make it more efficient to invest in particular types of things. And then, so that's all the input information. So what are we trying to get as output? Well, really what we're trying to do is we're trying to score each individual asset such that the score represents the personalized suitability of that asset for be it insertion into a portfolio at the current time. So effectively, what this represents is if we have a single asset, we want to produce a score for that asset. And that's really just what this equation is down here. And this is the most complicated equation because we're going to keep this talk fairly high level. So effectively what we want is we want to basically define a function which is going to take in information about a user at time t, so the current time, information about an asset at current time along with the environment, and we're going to go and produce a score that represents a suitability for the customer, where a higher score indicates higher levels of suitability. Okay. With that said, why would we want to have an automated system actually do this for us? Surely we can rely on financial investors or other types of experts to perform this for us, right? Because they have a better understanding of the market. And they can better take into account the personalized circumstances of the customer, such as how much they want to invest, the length of investment, target volatility, if they can understand significant known costs that the customer can tell them about, as well as how much they can afford to lose over any particular period. The problem, however, is really one with scale and cost, because if we think about it, employing expert financial advisors is very expensive. And that means that you're just going to have lower profit margins. The other point is if we're trying to move into a world where investment is open to everybody, then you're going to need to have a means to provide very low cost recommendations to your customers. And so having a personalized advisor for every single customer is going to be quite expensive. And so enter AI financial assistance as a potential solution to this problem. So automated financial assistants, or what might be called robo-advisors, are not new, right? So these are computer programs that analyze customer and market data and provide some form of financial advice. In our case, we're focusing on asset recommendation here. The actual field of financial assistance is much wider than that. We're looking narrowly at cases where you have an assistant recommending you particular financial assets. And these were first devised around about 13 years ago, and they're being increasingly common. So in 2018, it was estimated that these kind of automated systems manage around about $200 billion US dollars worth of assets worldwide, and that's only grown since then. And these type of assistants can be used in different ways, and that's largely dependent on the legal frameworks that exist in the region that you're working in. So in some countries, these type of assistants might be used directly by the customer. So for example, you have some kind of mobile app or an automated service, and you provide recommendation, and it basically provides your recommendations directly to the customer. In Infinitetech, we're actually looking at a different case where you're not directly serving the customers, but you're instead serving a financial advisor or otherwise a relationship manager inside a bank, where you effectively have a customer that comes into the bank, and then this is a support tool for the staff at the bank to be able to provide recommendations to the customer without having to have done an awful lot of background research into that customer. So actually it's there to try to take off some of the load off that staff member. Okay, so that gives us sort of the background of why we need sort of financial assistance and what we're trying to aim for here. So the next logical question is, okay, well, that's great. I would like to have one of these financial advisors. How do I go and make one? And so I'm going to talk a bit about how we can do that. So this is effectively a recommendation task. We have a set of assets, and we want to recommend those to customers. And you've probably interacted with a large number of types of recommendation system in the world, just probably not for the financial domain. So most people will interact with one of these systems probably every week, when they go to a shopping site like Amazon, and it gives you a list of recommended products that you might want to buy, and potentially filtered by whatever keywords you put into the search box. The other major sort of recommendation system people tend to think about is they think about movie services like Netflix, where you go to one of these services and it says here's a range of movies that you might want to watch. And critically, there's been a lot of research over the last decade into these systems, and because they are used by ever increasing numbers of proportions of the population, and these systems are money generators for these big companies like Netflix and Amazon. And so a lot of research has been going into making sure that these algorithms are very effective. And so a natural question is, well, could we go and take some of these algorithms and adapt them for the financial domain? And that's what I'm going to talk about here, and how well they perform. So just to give you some context on how recommenders work, because I know most of you are probably not from this type of community. So to give you some context, effectively what recommenders do is they take in 3 types of information, and this maps to what I talked a bit about earlier in terms of the task. So they take in information about a user, and that's typically your kind of background information and also interaction history. They take in potentially an optional query, so that might be to narrow down the scope of the items that you're going to recommend. You have some kind of world state, so this might be information about, well, in a shopping domain, it might be information about what products are on sale. In our case, for the financial domain, this might be information about market trends. And then you have information about your items. So effectively, in our case, these are our financial assets. So that's all of that, asset level information we talked about earlier. And what they do is they effectively encode all of this information into numerical vectors. They combine the numerical vectors for the user with the numerical vector for each item, and then they feed that into this black box machine learning model. And what that does is it outputs a score for each one of these items for a user. And what it's doing is it's trying to look at patterns with respect to these 2 vectors that's been learned on past examples. Now, I'm not going to go into exactly what's going on in terms of this box, because that's an entire presentation of it in and of itself. But to give you some context of the types of recommender that they are, you can basically break down your recommendation algorithms into 3 broad categories. You have what we refer to as content-based models. So what these are is these are looking at, or primarily focusing on, the similarities between a user's preferences and the attribute profiles of the items. Right? So an example of this in the financial domain would be looking at and saying, okay, these are high-risk stocks. The user is also high risk, hence there is a good match there. And you do that over lots of different attribute pairs to try and identify what's the best items to recommend. The other main type is you have collaborative filtering models. And the difference here is these are more focusing on past interactions from other similar users. So these are based on the theory of, okay, you are like these other people, and hence I'm going to recommend you things these other people that are similar to you bought. So you have these kind of two types. You have ones that are more based on the content of the actual assets, and ones that are more based on previous interactions with users like you. And then we have a third category, which is hybrid models. And these are simply the combination of typically content-based and collaborative filtering models together, or some other mix of algorithms. And recent research has shown that there has been significant advancements, particularly in the collaborative filtering field and these hybrid types of models. And so what I'm going to do is I'm going to show you some performances for insurance recommendation using a wide range of different recommendation models. And these are all available as open source from a public open source framework called Beta-Rexis that has been developed within the University of Glasgow and is open source. So you can download all these algorithms and you can try them yourself. So what are we going to be testing here? So we're going to be using a content-based model for comparison. So this is using user demographic information and also spending history of the customers, along with asset volatility for recommendation. We're going to be using association rule mining, which finds patterns with co-occurring item sets. We're going to be using a range of collaborative filtering models, ranging from sort of classical models like matrix factorization down to more advanced deep neural network-based models that are typically based on graph neural networks. And then we're also going to be looking at some hybrid models. So effectively what we are going to do is we're going to take these models here and we're going to combine them with our content-based model to get a hybrid recommender as well. In terms of what we're going to be evaluating over, so we're going to be using an insurance data set here that has different types of information. So in this, we've got actually around about 51,000 users, but only a small subset of those, about 1,000, have investment histories. We do, however, have demographic information for all of our users, such as age, gender, income, deposit account balances, card spends, and many other types of KPIs that we can use. Imagine the types of information that you might get from those questionnaires that was talked about in the first presentation. And we have historical asset pricing. So we have about 2.5 million data points from the last 4 years or so. And this covers assets such as bonds, mutual funds, stocks, and time deposits. So how well do these different recommendation models perform? So what this graph shows is it shows performance of different types of recommendation model for this data set that I just talked about. So along the bottom here, we've got our different recommendation models. So effectively we have content-based here, and this is basically a content-based block. We then have our collaborative filtering block in green, and then our red ones are our hybrid models. The metric we're using here is NDCG. So this is a ranking metric. So what we're doing here is we're taking all of the assets that we could recommend to the customer, we're scoring each one, and then ranking them by score. So where the highest scoring ones are at the top. And then the NDCG metric we're using here is evaluating to rank K, where K is 3. So what that means is it's looking at the top 3 recommended items, where if you have more and higher ranked your suitable assets for the customer, then you get a higher score. And that's basically you want more good assets in the top ranks, and you want those good assets to be as high as possible in the ranking. And we're focusing just on the top 3 because, well, if you're recommending items to the customer, you're probably not going to recommend that many items. So you want to look at just the top of ranks there. So that's how this works. In this case, the sort of horizontal bar indicates our average performance across customers. Oh, is there a question there? Yep. Okay. So the horizontal bar here represents your average performance. And then the sort of range here indicates the variance across the customers. So what do we take away from this graph? Well, first of all, there's maybe 2 main things that I want to take away from this graph. First of all, the basic sort of content-based and collaborative filtering models are not terrible. They're not amazing in terms of performance, but they're not terrible. So if we kind of sort of try and translate what this metric means, it kind of means that these models, you're probably, if we look at the top 3 recommendations, about one of those is probably highly suitable for the user. And if we compare that to then these hybrid models where we're combining both the sort of collaborative filtering and the content-based evidence, then we get a large uptick. So we're now in space where we're getting maybe around about 2 out of every 3 recommendations in the top ranks are, you know, good quality recommendations for the particular customer. So that's good. That indicates that actually, yeah, these models are, you know, pretty effective, right? Which is maybe what we would expect given the amount of research that would be going into developing these for other domains. The other thing that I would note, which is maybe not obvious to someone who hasn't worked in this field, is that these models, so these collaborative filtering models, are actually are performing fairly poorly for this task. And this is actually a notable difference for the financial domain in contrast to things like your movie recommendation or your shopping recommendation tasks. And that's mainly because we actually don't have a lot of investment history information, which is, you know, sort of flipped if you're working in these kind of movie recommendation domains where you have a lot of interactions. And because, again, most people are not investing. So we don't have a lot of that type of history. And so we need to leverage other sources to determine what is a good thing to use or a good asset to recommend. However, the other thing to take away from this is we're not perfect. So we're still maybe, you know, every 1 in 3 items are not suitable. So we need to make some more progress there. And at the end of this presentation, I'll talk a bit more about, you know, different approaches to do this. So that's a look at performance. So let me just quickly now break out and give a short, you know, view on what this would actually look like in terms of, you know, from a customer, right? So if I was actually going to, you know, use one of these systems. So let me bring this up. So this is one of our sort of early prototypes for performing asset recommendation using these your machine learned or deep learned models. So the idea is you can imagine that your customer enters like the bank and sits down in front of their relationship manager, and they say, okay, I'm interested in doing some investments, or maybe the relationship manager prompts them to think about investing. And so the relationship manager then wants to go and get a quick overview of that customer and have some idea of things that they might want to initially recommend for them to invest in. So they could maybe put in their details and select the customer. This is all anonymized data for one particular customer. And so here we might see you've got some information about the actual customer themselves. They have information about their income, you have information about their current balance and their balance histories, and you might have some estimation of their existing your risk appetite. So think about the types of information you saw in the questionnaire in the first talk. This is the kind of information you would put here. And potentially you might also visualize past investment history for the customer, if they have some, and also information about maybe their other banking history as well, if you're dealing with a customer that doesn't have any investment history. So you can see maybe what they've invested in the past. We can see for this particular example that I just picked at random, we've got, you know, this seems to be a pretty big spender, right? So he's probably fairly well off. He's had some investments before. And then what we do is we also have our personalized recommendations. So this is one of the things that we're currently looking at different ways you can visualize this. So this is what we call the sort of return risk grid or risk return grid, where you can take your recommendation set, so maybe your 100 or 50 or 1,000, whatever number of recommendations that you're producing, and you could go and break those down into your different dimensions. So where does this exist on a risk return scale? So for example, I wanted to go and click over here and say, okay, I want to look at the different assets that exist in this particular category. Then I can go and visualize the different types of assets that you have or follow that type of risk return profile. And then based on my discussion with the actual customer, I could better refine the types of recommendation or types of products that they would be interested in purchasing. Okay, so that's how this might look if we were actually going to, you know, provide that as a product. So let me just finish off this talk by talking a bit about where are we going, right? What are we going to be doing later on in INFINITECH? And also, what are some of the interesting developments that, you know, are actually coming down the pipe in the wider field that will affect how well this type of insurance task can perform. So I'm going to mainly focus on kind of like limitations of existing systems, and then some of the technologies that can kind of maybe improve this. So the first one I wanted to highlight was looking at encoding knowledge from the future. So what I've been talking about so far is I've been talking about automated algorithms for recommendation that are naturally focused on using the past as a means to predict the future. So these are all looking at either past investment histories for the customer, past asset histories in terms of their pricing. And these are good features, right? We're not saying that these are bad ways of provide or estimating what to invest in. However, we also have to bear in mind that we might have some knowledge of what's going to happen in maybe the near or indeed long-term future. So the customer may know about changes in their financial position well in advance of those factors coming within their control. So you have things like, okay, they're planning to start a family, they're moving job, they're going to buy a house. These types of things we would want to be able to know about so that we can integrate that when we are actually performing recommendation. Similarly, if we're doing things like stock, or stock recommendation, then the underlying companies publish information about their upcoming products. We know that these are going to affect the profitability of the actual company, and hence will affect their share value. So we'd want to be able to encode that information into the actual model. And similarly, you might have other government initiatives that are being instituted and international politics that can affect the entire market segments. And so I think the next generation of these types of recommendation algorithms will be able to start to integrate these types of future information, either doing some kind of future event modeling, which they don't currently do. The second kind of main area that I think is very interesting, and we're seeing some significant progress, is in the textual frontier. So, the models that we looked at today are primarily focused on numerical data. So all of these stock prices and numerical representations of user risk and the expected return and all these types of things. However, while these are really good features, the issues with them is that they represent market reactions, not the cause of those reactions, meaning it's very difficult to get ahead of the market if you're trying to do investments. And so the natural solution to this is to look at or try to more directly track market shifts from the earliest point in time that we can observe them. So this is typically via financial reports, maybe in the call logs from investor calls, and also tracking news stories to try and identify what are the sort of things that are going to drive the market market shifts that are going to happen. And one of the sort of major advances that we've been seeing over the last 3 or 4 years is in neural language models that make it much easier and much more effective for machine learning algorithms to reason and understand, complex pieces of text. And so it may be possible in the short term to start to have automated systems that can not only analyze these pieces of text, but can start to reason about the impact of market changes from those texts. There's also a secondary ancillary benefit from this as well, which is these types of neural language models are also making machine translation or automated machine translation significantly more effective. So this opens the doors to being able to integrate more multilingual content into your models if you want to do that kind of text analysis, which is really useful if you're doing trading in stocks across language boundaries. The last thing, and I mean, we had a question on this earlier, was about automated trading systems. So what we're looking at currently is we're looking at very much sort of a support tool for a human, where that human is going to, you have to approve any kind of recommendations that we give them. However, the natural question is, of course, well, what if we wanted to place decision-making powers in the hands of the actual automated agent rather than leaving it all up to the human? And the important thing to realize is this is happening today, right? So a recent study by Reuters indicated that about 70 to 80% of shares traded on the US stock exchange come from automatic trading systems, not humans. So this is already happening. And so we need to start to think about, okay, how can we integrate this type of information? So because these automated systems have a number of advantages, and particularly when you're looking at quickly making shifts in your portfolios with respect to market changes, and to maybe tackle emerging risks for the customer. So for example, if you have a customer where you know that they are going to need to draw down their investment because they have some kind of maybe big purchase that's coming up at a particular point in time, and then you suddenly start to see a market shock, it might be time for that customer to sell out because they won't have or they will need to draw down their investments before the market will recover. So those are kinds of things where you'd want to go and do very rapid sort of alterations of the actual portfolio of the customer, and automated systems are an effective way or a good way of actually doing that. Okay, so I probably talked for far longer than I should have. So I will open the floor to questions, or if you want to contact me privately, you can contact me at this email address here.
Thank you, Richard. Unless there are any other questions, I think it was a very insightful presentation. I don't know, do you have a demo or?
That was just, I showed the UI. That was as much as I had for that one.
Okay. Very good, very insightful presentation. Unless there are any other questions, well, I would like to ask you something, but maybe we can do it in the end so that we can break people, if you agree, right? We can give a 5 minutes break. I'm gonna stop the recording and we are back in 5 minutes with the VIR presentation and the high frequency trading, and then the wrap up and any questions overall. I will also provide in the next session a link to the survey. Oh, yeah, we've got a question, right? So maybe, yeah, Hayet, you wanna ask this question? Maybe this is for Richard.
I don't see here. So the question is, yeah, how much are you integrating textual analysis already?
Yeah,
yes.
Yeah. Thank you very much.
Yeah. So the models that we were presenting here.
Reconveying that.
Yeah. So the models we're presenting here are not integrating textual evidence, right? We currently are working on integration within the Infinitetech project with ReportBrain, which is doing real-time sentiment analysis on news streams. So that should be getting integrated into these models soon. What we are actually wanting to do in the second half of the Infinitetech project is actually a bit more deep textual analysis, though. So trying to move beyond simply looking at your sentiment changes with respect to particular companies or other entities of that kind, to instead trying to do a bit more reasoning about the effect that particular changes actually have. So that's moving beyond just going, oh, look, people are happy about a stock, to instead saying, okay, this particular event has happened, which is related to the stock. And then that is going to have like a 3% impact on pricing, and seeing if we can start to learn these more accurate effects rather than just looking at, okay, people are happy or they're sad. Hopefully that answers your question.
Okay, very good. Thank you very much, Hayed, for the question. Thank you really very much. So I suggest that we've got a 5 minutes break, right? Maybe more 5-7 minutes break so that people can relax, have a coffee, and then we have another 2 presentations to close the workshop, and we will ask you, we will administer a survey and so on. So yes, see you in 5 minutes. I'm stopping the recording and I will start it. When we come back, okay, let's say 10 minutes past 11 Central European time, we will recap the presentation of the workshop. And thank you again, Richard, for the discussion, for the presentation.